Welcome back to Soft Spoken Scientist. Today we're going to do one of the most important building blocks in algebra, combining like terms. This is going to let you do all kinds of things and all types of steps. If you've ever looked at an expression and thought, wait, what can I even combine? This video will finally make it click. Let's jump straight in. So, as you see, like terms means same variable and same power. Okay, so I'll list some examples on that soon. And like terms means the terms have the same variable raised to the same power. So 3x and 7x. Those are like terms, right? So we have an integer, which is 3. We have an integer that is 7. We have a variable that is x and also x. So they're like terms. Is 4y and 9y like terms, you guys? Yes, it is. Hopefully you said yes. Okay. Now, remember, like terms have this means the terms have, long day, means the terms have the same variable raised to the same power. So we have 3x and 7x. Now, 4y and 9y. So we got those right. But let's talk about the power. It's another thing that's invisible in algebra that they don't always talk about. And you guys know how I am about that. So everything that doesn't have a number in front of the variable is raised to the first power. If there's no number, assume it's raised to the first power. So again, we have a number, a variable, and an integer. The variable and the integer agree. And then we have a number. It doesn't need to be the same exact number, right? But we need it to be the same variable raised to the same power. And we have that, and we have a number. I think you guys got I think you're picking up what I'm putting down. But if I had 3x and 3x squared, are these like terms? No, they're not. Remember, I told you guys, if there's no number, assume it's raised to the first. Is this the same as that? No, because one's raised to the second, one's raised to the first. Not like terms. What about 4x and 4y? Are these like terms? No, they're not. These are completely different variables. When terms are like terms, you just combine the coefficients, the numbers in front. So let's do problem 1. The instructions are simplify, right? You have 3x plus 5x. These are like terms. Same variable, x, same power, which is 1. Combine the coefficients, just like you would regularly. You have 3 plus 5. It's 8. Bring down the x. And you have 8x as your answer. Now, if I told you we have 7y minus 2y plus y. Well, all terms have y in them. So, I'm going to do 7 minus 2 plus 1. There is an invisible 1 in front of a variable that doesn't have a number in it. So what is 7 minus 2? That's 5. What's 5 plus 1? 6. So the answer is 6y. 7y minus 2y, 5y. 5y plus 1y, 6y. All right. Now we're going to simplify this one. We have 4x squared plus 9x minus 2x squared plus 3. Right? That's a bit of a doozy. But we're just going to group like terms. So we have 4x squared minus 2x squared, right? These look like terms. 4x squared minus 2x squared. What's 4 minus 2? 2. Oh, x squared and x squared are the same. Bring it down. Boop, boop. These are the same. Bring it on down. Easy and simple as that. You're not going to cross off and say, well, x squared minus x squared. No. You bring it down with you. And you're going to see this when you later do your quadratic formula and all types of other things. 9x is going to stay the way it is because there's nothing I can combine it with. I can't combine it with the 2x squared. I can't combine it with 3. So I'm just going to bring it on down. So the only thing that I have is plus 3. Is there anything that I could combine that with? No, it's not an x squared. There's no, granted, if it said 3x, I definitely could do 3x plus 9x, but it's just an integer on itself, on its own. So this is a final simplified expression. So this would be your answer. Okay, let's simplify 5a plus 4b minus a plus 2b. Looks scarier, but it's same concept. I'm going to combine the like terms by grouping the a's and the b's. Okay, I have 5a minus a. Remember, there is an invisible number in front of the a, and that's a 1. 5 minus 1 is 4. So I'm just going to bring down the a. So 5a minus a is 4a. Simple as that. We have 4b plus 2b. And I know that it's a plus 2b because I see the positive sign in front of the 2b. So I have 4a plus 6b. And this would be the final answer. What if I said 6m minus 3 plus 2m plus 10? 6m plus 2m. 6 plus 2 is 8. I'll bring down the m. Now, we have minus 3 plus 10. This may, trick people, but just draw a number line. You have negative 3, and you're heading towards, this is heading to infinity. Let me be very, very clear. This is heading to infinity. Anytime you see a number line, it heads to infinity. We're heading that way. We're heading to negative infinity. Here, we're heading to positive infinity. Okay? So negative 3, what's going to get me closer to 0 in the positive numbers? Negative 4 or negative 2? Would you rather, let me say it like this. Would you guys rather be in debt to someone by $2 or $4? I'd rather owe someone $2. So that's closer to getting out of the debt. Then negative 1, then 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know why I did that, but okay. So I'm going to add 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But ka-ching, right? So that is 7. So we have 8m plus 7 as our final answer. All right, that's today's quick lesson on combining like terms. If this helped you, please don't forget to tap like. It really helps the channel grow, and subscribe so you don't miss the next algebra lesson. Thank you guys so much for learning with me, and I'll see you in the next video. You're the best.